Today, we're going to talk about improper rational function integration. And the idea is that we have some sort of, pfx over qfx where if the degree of the numerator is greater than or equal to that of the degree of the denominator, then we got to use long division to solve it. And we put it in this form where we have m of x plus r of x divided by q of x. What does that mean? Well, r of x is a remainder and q of x is simply the quotient. Okay, and so that's the general gist. So what if we wanted to integrate this? Well, notice that the highest power is actually equal in this case, and so in this case we got to use your long division. And so we know we're going to take out our fraction bar. Okay, and essentially what I'm doing is that I'm sticking the numerator under the fraction bar, so this becomes 2x squared plus 4, and the denominator becomes outside. Okay, and the idea is now I'm going to ask myself, what number can I multiply x squared by, the highest power, to give me 2x squared? And that answer happens to be 2. Okay, and now that I find 2, all I got to do is just multiply. So I distribute, so 2 times x squared becomes 2x squared, and 2 times 1 becomes 2. Now once I'm fully done distributing, I'm going to put our parentheses and subtract all that from underneath my fraction bar. Put a minus sign, okay? And so the idea is 2x squared plus a minus 2x squared, that happens to be 0. So we don't care about that. Let's put the 0, okay? So this is 0, okay, plus, well, positive 4 minus 2, that will always give us a positive 2. So there's our remainder. So there's r of x. Okay. Here is q of x. And here is m of x. This is our quotient, so this is m of x. Okay. So the integral just says that we're going to take the integral. We're going to write m of x, so this becomes 2 plus, well, what is r of x? That is a remainder, so that is 2 over q of x, which is x squared plus 1 dx. Okay, now we know the integral of this. If I split my integral up, this becomes the integral of 2 dx plus the integral of, because I have a constant here, I could just bring it out. So this becomes 2 times 1 over x squared plus 1 dx. And we know the integration here. The integration is given by, integral of 2 is just 2x plus 2, well, this is tangent inverse, so 2 times tangent inverse of x plus c. Okay, and this will be your integration. So again, nothing more difficult. Let's look at one more. So, well, if we want to take the integral of 2x squared minus 4x squared minus x minus 3 dx, and we divide that by x squared minus 2x minus 3. Okay. If I look at this, my fraction bar, I draw my fraction bar. Okay. Again, I'm sticking the numerator underneath the fraction bar, so this is 2x minus 4x squared minus x minus 3. And just dividing by the outside, so this becomes x squared minus 2x minus 3. Okay. Now again, the idea is that what number can I multiply this first term here to get the first term here? I can multiply this by 2. I'm sorry about this. This is an x cubed. So I'm sorry about this. This is the 2x cubed. And this is the 2x cubed. So I forgot my cube there. Okay. And so the idea now becomes, what number can I multiply x squared by to get 2x cubed? Well, it looks to me if I multiply x squared by 2, I get 2x squared, but I need cube, so I can multiply by one more x, and that will give me 2x. If I multiply x squared by 2x, I get 2x cubed. And so now I could go ahead and distribute. So if I distribute, 2x times x squared becomes 2x cubed, okay, and minus 2x times positive 2x, that will give us a minus 4x squared, and then minus 3 times 2x, okay, minus 3 times 2x, that will give us a negative 6x. Okay, now the idea now becomes that we got to put everything in parentheses and subtract. Okay, and so with distributing or negative sign, negative 2x plus 2x, that will give us a 0. Okay, negative times a negative is a positive, and so positive 4x squared minus 4x squared. That's also 0. So let's put a plus sign, 0 plus 0. And then a negative times a negative is a positive 6x. So this becomes positive 6x minus 5x. Well, that is always going to give us a positive, positive 6x minus x. Well, that is always going to give us a positive plus x. And notice that we have nothing else to distribute, so we just bring down our negative 3. So this becomes 5x minus 3. Now, in fact, this is actually a remainder. Okay, so this is actually r of x. And whenever you notice this here, remainder is whenever the highest power is actually lower than the highest power of your q of x. Okay, and so there's because this power is low, we're finished. This is a remainder. We can't go any further. Okay, and so we know the general integral is going to be given by m of x. Well, let's label. We know this is r of x. We know this, so we know this is r of x. Well, where's my m of x? This is here. So this is m of x, and here's your q of x. Okay, and so if I look at this, well, it looks to me as if my m of x is 2x, so this becomes 2x plus, well, r of x is 5x minus 3. And I'm going to divide that by q of x, which happens to be x squared minus 2x minus 3 dx. Okay, so how do we integrate this? We know the integral of this. How do we integrate this? Well, again, it looks to me as if this is a partial fraction integration. Okay, so if you have not seen by now, this is a partial fraction integration. This integration is actually much more harder. Okay, so if I look at this, the integral of 2x is actually just x squared plus the integral of 5x minus 3 over x squared minus 2x minus 3 dx. Okay, and again, I'm gonna go ahead and let you try this for yourself, but again, this is integration by partial fractions. Okay, and as you can see, my factors, in fact, and I'm not going to do it, but if I'm just looking at this part of the integral, then this becomes the integration of 5x minus 3 or x squared minus 2x minus 3 dx. And notice that my factors are 5x minus 3 over x minus 1 times x plus 3. Well, no, this is x plus 1, x minus 3. Should be opposite, right? Because negative 3 times positive 1 is a negative 3. And if I add them together, I get a negative 1. Okay? So if I add them together, I get a negative 1. I get a negative 2. I'm sorry about that. If I add them together, I get a negative 2. Negative 3 plus 1 is a negative 2. If I multiply them, I get a negative 3. And so, in fact, we could decompose this into 5x minus 3 over x plus 1 times x minus 3. And that is equal to a over x plus 1 plus b over x minus 3. Okay, and so if we do this, this becomes 5x minus 3, and that is equal to a times, we have an x plus 1 in common, so this becomes a times x minus 3 plus b times x plus 1. Okay, and the idea is that if I set a, I said I wasn't going to do it, but I might as well do it. Okay, and look, if we set x to be equal to positive 3, then we could get rid of a. So this becomes 5 times 3 minus 3, and that is equal to 0 because 3 times 3 is 0, plus b, which is 3 plus 4 happens to be 4, so this will be 4b. Okay, 5 times 3 is 15. If you subtract 15, 5 times 3 is 15. We subtract 3 from that, that will give us 12. So 12 is equal to 4b. So therefore, we know that b is equal to 3. Because 4 divided by 3, 4 divided by 12 is 3. Okay, and so we found b. And so what could we set x is equal to solve for a? Well, it looks to me as if I set b is equal to x is equal to negative 1. So if x is equal to negative 1, then this becomes 5 times negative 1 minus 3, and that is equal to a times negative 1 minus 3 plus 0. Okay, negative 1 plus 1 is 0. And if we multiply 0 by b, b goes away. And so 5 times -1 is -5 minus 3. That happens to be -8. And that is equal to -4a. -1 minus 3 is -4. Essentially, if I divide by -4 on both sides, we get a to be +2. Okay, so we know what a is. We know what b is. And guys, as I'm doing this integration by partial fractions, you should not forget that I have this x squared here. Okay, so I'm going to attach this x squared here at the end. Okay, and so if I look at this now, this now becomes the integral. This now becomes the integral of a over x plus 1. So this becomes a over x plus 1 plus b over x minus 3 dx. Okay. Now we know what a is. So this now becomes the integral. So this now becomes the integral of a, which is 2 over x plus 1 plus b, which happens to be 3 over x minus 3 dx. Okay, if I take my integral, this becomes 2 times the natural log of the absolute value of x plus 1 plus 3 times the natural log of the absolute value of x minus 3 plus c. Now don't forget, I had my x squared in. So I just took care of this, had my x squared here. And so I'm going to attach that on to the front. So the actual integral now becomes x squared plus 2 times the natural log of the absolute value of x plus 1 plus 3 times the natural log of the absolute value of x minus 3 plus c. And this will be the actual integration. Okay, so you could see that some of them get really complicated. Well, this one wasn't that bad. I was just not expecting the partial fractions, but we did it. And so that's the idea behind the improper rational function integration. Okay, if the numerator, the highest degree is equal to or greater than that of the denominator, then we got to use this idea of the long division thing.